work on Leetcode 1210. This is also a hard question. The title is Minimum Moves to Reach Target with Rotations. So this is in general a maze problem, and what's the difference here is that it doesn't the object is not just one point. It is some obstacles that can move uh, like counterclockwise or clockwise. So as shown here, so each time this snake has only spanned two cells, so it's either horizontally or vertically occupied two cells, and each time it can either move one cell to the right or one cell to down, or rotate clockwise or rotate counterclockwise. So the condition for the snake to move uh, clockwise is that the two positions under this snake are both zero. And similarly, if you wanted to move counterclockwise, the two cells on the right side should be also be zero. So the question asks us that to get the minimum number of moves from the top left to bottom right, and also the position of the snake should be stay horizontally. So it first located at 0, 0, and 0, 1. Then it should located at n minus 1, n minus 2, and n minus 1, n minus 1. So this is a quite interesting problem, and we can just naively to search based on the state of the snake, right? So we can define state as just the position of those 2 points, x1 and x0, y0 is the first grid point, and x1 and y1 are the second grid. So if you define state like this and use a queue to store the states, then to use BFF search, you will get the solution. Yeah, you will pass this problem. It's not that hard. You just need to implement it very carefully. However, you can do this question problem quicker because those number in the state are not independent, because whenever you know the position of x0 and y0, you at least know one number of x1 and y1, right? You either know x1 or y1 depending on whether this snake is vertically or horizontally. So you can define the state like this: x, y, and direction. This is the state. So this means, for example, you are at 0, 0, and 0, 1. This actually equal to the state 0, 0, and if we say 0 is horizontal, then it's 0, 0, 1. If it's vertical, then there's a 0, 0, 0, 1 is for horizontal, and 0, 0, 1 for vertical. So in this way, we can actually write the BFS based on this state definition to save some time. So we define the node as the x and y, and also the direction for D. Direction 0 horizontal. Is vertical. Right. Then we write a constructor. Node x, y, and D. Okay, so x is just x, y is just y, and D is just that's it. Then we define a queue. So we have the initial grid, node as the init, which is equal to 0, 0, and horizontally, right? And how about the last one? And if the grid size is n, the last node is destination. It is n minus 1, n minus 2, and also horizontally. Okay, this is the destination. Then we have a queue of node, queue, and in order to know which state we have visited and not, we use some state visited. So the number we use in this problem is pretty small, so we just have 1, 10, and the grid is either 1 or 2, so we so the direction is just have 2 values, so this is 2 here. Then remember we need to mem set this visited, set it to 0, and size of visited. Okay, and initially queue should push init, and also visited 0, 0, 0 should be set to 1, then we can start the loop. So we have this res returns the number of steps. Then each time we first get the size of this queue, then we do the while loop for all the members in this queue. Then we increase res. Then we return -1 at the end, and then we return something inside this while loop, right? So we get the front element, this at front. Remember to pop it. This is all. Sometimes you will forget it, and the program takes a long time. This can save you a lot of debugging time if you have the habit to just pop it after you get the element from the queue. Then if f equals the destination, then we know we are we have reached the destination. Then we just return res, right? Otherwise, we can put it in one line to save some space. Otherwise, we will continue to work on to add those states inside this to add those states to this queue. So if fd equals 0, this means horizontal, right? Then another condition is just vertical. If it's horizontal, then the way we can do our we can only have 2 ways. One way is just move to right. Okay. Let's see. Yeah, we have 3 ways. One is to move to the right, and another is go down, and then another is rotate clockwise. So the condition for rotate clockwise is the same as condition to go down. So we separate into 2 conditions. So if now we check for moving right. So this is for right. If we need the right grid. The right grid is y is fy plus 1 and plus 1 again if it's less than n, and the grid at that corresponding place, it is f dot y plus 1 plus 1 equals to 0. We can move right, right? So and if visited x is fx, y is fy plus 1 plus 1. So this is plus 1 here, right? Plus 1. If visited equals to 0, then we can add it into the queue. Visited, this is horizontal, right? This is fd. Then we can add this to this queue. Queue is queue push, and we need to construct a node. It is fx and fy plus 1, then still horizontal. And we update the visited. We visited should be y plus 1, I think, right? Because we are always using the position of the first grid as a state. So this is like this. This can be set to 1. Yeah, this is the first situation. And the second situation is actually to check whether those 2 points have grid 0. So in order to do this, we just define some new variables. X equals to f x plus 1 and y equals fy. If x less than n and grid x y equals to 0 and grid x and y plus 1 is also 0. Then let's see. Oh yeah, so actually this is not inside if. So yeah, this is done and rotate. Then we copy the code here and modify. So this is one, this is another. First we check if we can go down. So this means we check visited x and y. And horizontal, right? Horizontal. If so, we can put the new states inside the queue. It is x, y, and horizontal. Then we change x, y, horizontal to 1. So this is go down. And then rotate. In order to rotate, we should go from horizontal to vertical. So this is 1. Then x does not change. Still fx, and y does not change. It's still fy. Then what we are going to push is fx fy, and here is your 1 minus fd, but we just put it 1 here because it's pretty clear. And visited, we add this state to 1. Okay, then rotate is done. And then we are going to deal with thing like vertical. Vertical, the code is tedious, and we just copy paste all the code for the first situation. Okay, so we put it here. So the first, we check whether it can go down. Then second, we check whether it can go right and rotate, right? Because those two situations are identical in this scenario. This scenario is vertical. So it's for this scenario, go right and go rotate counterclockwise are situations are identical. So first we check if we can go down. If we can go down, that means fx plus 1 plus 1 should be less than n, and grid fx plus 1 plus 1 and fy should be 0. Okay, then the new state is fx plus 1 fy. This is still vertical, so this is 1. So we push this state into the queue. This is 1, and we set visited to 1. And this is 1, I think. Yeah. So we're done with go down. Then we check for going right and rotate. So in order to go right, the x are identical, but y is different. Y should be equal to fy plus 1, right? So if y less than n and grid grid xy equal to 0, then grid x plus 1 and y should also be 0. Then we can go down and rotate. In order to go down, x becomes x plus 1, so fx plus 1, and y is the same, and this is go. In order to go down, x becomes fx plus 1, then y is the same, then still vertical. And here it is fx plus 1, y, and 1 is and push. And here it is fx plus 1, y, and 1. We set this state. Then we deal with rotate. For rotate, x and y doesn't change. We only change the horizontal to vertical, to horizontal. Then we can put this inside the queue, and then I think we are all set. Okay, let's try. I think we need to define the equal operator, right? Okay, let's see. Invalid. Oh, this is equal. Wrong answer. Let's see what's happening. So let's read the code again. So we have defined this struct node, have its constructor function. Oh, I think there's something wrong here. This should be D, right? That's incorrect reference binding. Okay, let's see. X, Y, D, X, Y, D, right? For operator, it's X equal other X, and Y other Y, D other D. Okay, and we have this visited three-dimensional array to remember which state we have already visited. So we set it to 0 at beginning. And then the initial state is 0, 0, and horizontal. And the final state is n minus 1, n minus 2, horizontal. Then we set visited, the first state as 1, and we push the initial state into Q. And we use RES to remember the number of steps. And we do a while loop, and each time we just deal with all the members in the queue altogether, because that is what we can reach for some certain steps. And after we deal with that, we increase RES by 1. Then inside this nested while loop, we do first we get front, then Q pop. If it's equal to destination, we just return RES. Then if FD is 0, this means it's horizontal. Then we check if we can go right. The way we can go right is we check Fy plus 1, and then plus 1 again. This is the right position. And we check if the grid is 0. If it's 0, then we can move to the right. Then that is x and y be increased by 1. And we just say it's 0 here to make it pretty clear. And we can put x and y plus 1, 0 into this queue, and visited is updated to 1. Okay, so this is for the right. And then we check down and whether we can do the rotate. So for down, x is increased by 1, y is the same. So we need to check if the new x is less than n. If so, we check whether the grid xy and xy plus 1 are all equal to 0. This seems to all equal to 0. Then we can move down. We move down, we check if this position x and y is visited. It's still horizontal. Yeah. If so, if not visited, we push and update. Then we check if we can rotate. In order to rotate, after we rotate, it will become vertical. So x and y doesn't change, and this becomes vertical. So we put this new state inside this queue. It becomes vertical. Okay, this seems right. How about vertical case? Vertical case, we first check we can go down. In order to go down, it's fx plus 2 should be less than n. Then the grid fx plus 2 and fy should be equal to 0. Then we check if the new state is visited. So x plus 1 and fy and 1. This is a new state. It's not visited. Then we push this new state. So x plus 1, y and 1. Then this is x plus 1, y 1 equal to 1. Okay, then we check if we can move right or rotate. In order to do this, the y should be moved 1 step on the right. So x is fx, y is fy plus 1. Then if y is less than n, and we check grid x and y should be equal to 0, and grid x plus 1 and y should also be equal to 0, right? Then we can go right. This is right. In order to go right, the new state is fx and y is x and y, right? Then we have some back here. x, y, and 1. And we also update x, y1 to 1. So this is moving right. And another way is rotate. Rotate is counterclockwise rotate. So x and y doesn't change, fx and fy. Then we change from vertical to horizontal. Then xy horizontal. So let's see if this works. Yeah, this will work. And let's submit. Okay, it passed and beats 98.89. Okay, thanks for watching and see you next time.